આમાં મેઇન સમજવાનું બે જ પોઈન્ટ છે. કેસ 1 કે જેમાં તમને સીધો h nu મળે છે અને કેસ 2 in which you have to go for the parabolic shape, right? EC plus and EV minus. If you are considering E1, then EV minus, and if you are taking E2, then EC plus. Understood, everyone? Then the thing is all related to mathematics. Barabar છે everyone?
Yes, ma'am.
Yes, ma'am.
Fine.
Yes, ma'am.
Yes,
So
Megha, start.
h nu is equal to Eg plus h square k square by 2 into 1 upon mc plus 1 upon mb. By simple term માટે 1 upon mc plus 1 upon mb is equals to આપણે 1 upon mr લઈએ. So h nu is equal to Eg plus h square k square by into 1 upon mr. હવે k square ને સબ્જેક્ટ બનાવી તો k square is equal to h nu minus Eg into 2mr by h square, where k square Ec, mr, mc, Eg is constant, so and only E2 and nu is variable. Now we substitute the value of k square in equation E2 and E1. So E2 is equal to hc plus h square by 2mc h nu minus Eg into 2mr h square. So E2 is equal to Ec plus mr by mc into h nu minus Eg, and E1 is equal to Ev minus mr by mv h nu minus Eg. So rho of V is equal, એટલે કે density of states is equals to number of states per unit volume available for photons energy between h nu and h nu plus d nu to interact either absorption or emit. Emission process થાય કે absorption process થાય, h nu અને h nu plus d nu એટલી એનર્જી માં કેટલા number of કેટલા states છે એ છે number density of states. Second slide ma'am. So the total density of states is equal to density of states in conduction band. So rho nu into d nu is equal to rho c E2 into dE2. So rho nu is equal to rho c E2 into, હવે આ d nu છે એ ઓલી સાઈડ જાય તો છેદમાં જશે. So is rho c E2 by into d2 by d nu. From equation number 4, we differentiate it with respect to nu. So E2 is equal to Ec plus mr by mc h nu minus Eg. એ આપણું E2 હતું એને હવે એને આપણે ન્યુ સાથે ન્યુ ના રિસ્પેક્ટ માં ડિફરન્શિએટ કરીએ તો dE2 by d nu is equal to mr by mc into h. Above density of states, we prove that rho c into E2 is equal to 4 pi by h cube 2 mc raised to 3 by 2 E2 minus Ec is a raised to 1 by 2. આ density of states માં આપણે prove કરેલું છે. From equation number 6, rho nu is equal to 4 pi by h cube 2 mc raised to 3 by 2 E2 minus Ec raised to 1 by 2, and dE2 by d nu ની વેલ્યુ આપણે ઉપર 7 નંબર ના ઇક્વેશન પરથી mr by mc into h. Next slide.
Students, clear થયું બધાને?
Yes, ma'am.
It was mathematical operation. The thing is તમારે બે equation યાદ રાખવાના છે. E2 minus E1 થશે, but E2 minus E1 how it would occur? By considering E2 is equal to Ec plus term, and by considering E1 is equal to Ev minus term. Understood? We want to see the density of photons present for that transition. Clear, everyone?
Yes, ma'am.
Yes, ma'am.
Yes, Megha.
Yes, ma'am. Rho nu is equal to 4 pi by h cube into 2 mc raised to 3 by 2 in and EC plus MR by MC, H nu minus EG minus EC. So EC cancel, raised to 1 by 2. EC cancel. So 4 pi by H cube into 2 MC raised to 3 by 2 into MR by MC, H nu minus EG raised to 1 by 2 MR by MC into H. So 4 pi by h cube 2mc raised to 3 by 2 mr by mc into raised to 1 by 2 eg minus h nu minus eg raised to 1 by 2 and mr by mc. So mr by mc ની કુલ total 3 by 2 power થશે. So 4 pi by h square 2 mc raised to 3 by 2 h nu minus eg raised to 1 by 2 mr by mc raised to 3 by 2. So ઉપર નીચે પાઈ વડે ડિફરન્ટ પાઈ વડે ગુણાકાર અને ભાગાકાર કરીએ તો 4 pi 2 pi by h raised to 2 1 by pi 2 mc raised to 3 by 2 h nu minus eg raised to 1 by 2 mr by mc raised to 3 by 2. So h upon 2 pi is equal to h cross. So we can write that 1 by h cross square into 1 upon pi 2 mc raised to 3 by 2 h nu minus eg raised to 1 by 2 mr by mc raised to 3 by 2. So our equation rho of nu is equal to 1 upon h square pi 2 mr raised to 3 by 2 h nu minus eg raised to 1 by 2. So this final equation is called joint density of states. This is the expression for joint density of states which shows or tell us about how many absorptions and emission takes place. Thank you.
Perfect, Megha. Very well done. So students, can you tell me how many number of absorption process or how many number of emission process would take place? Would it be given by equation number? Students, my question is, do we come to know that how many absorption process or how frequently the absorption process would occur? Can we judge it by using equation number 9? Equation number 9 શું બતાવે છે મને કહેશો એ rho nu? What is that rho nu?
Density of states, joint density of states.
Joint density.
કોની ઇલેક્ટ્રોનની, એટમની, ફોટોનની, કોની?
Photon.
ફોટોનની. So obvious છે rho nu એટલે incoming photons will decide if rho nu is very high. If rho nu is very high, can you say absorption rate would be higher? Absorption rate? हाँ के ना?
Yes.
Okay. In the same way, when emission would occur, when you think about h nu, when emission would occur, that also tell us that how much emission rate is associated with this process. Emission rate. એટલે rho nu initially it would be absorbed, then after it will emit certain photon. That would be decided by rho nu. Maximum number of photons you are imparting on the system will tell us maximum number of absorption process will occur. How frequent your absorption process will occur. Understood? Shall have you? I think there is confusion. કોઈ જવાબ નથી મળતો એટલે. Is there a confusion, students? Is there a confusion? એનો તો
મેમ
મને હા કે નામાં જવાબ આપ.
જરાક રિપીટ કરજો ને પેલું તમે બોલ્યા તે પછી.
શું
પહેલા
રિપીટ કરું?
પહેલા એબ્ઝોર્પ્શન થશે પછી એમિશન થશે તેના પછીનું.
રો ન્યુ એટલે કેટલા નંબરના ફોટો તમે ઇમ્પાર્ટ કરો છો સિસ્ટમ પર. રો ન્યુ વધારે હોય તો ડુ યુ થિંક એબ્ઝોર્પ્શન પ્રોસેસ અથવા એબ્ઝોર્પ્શન રેટ વધારે હોય?
યસ મેમ.
હા, તો ઇઝ ઇટ ડિપેન્ડન્ટ ઓન રો ન્યુ?
યસ.
Number of incoming photons, number of incoming photon density will surely give you high absorption rate as well as high emission rate. Is it true? Can
Yes.
we say it is coming from equation number 9? Equation
ma'am.
number 9 આપણને એ જ કહે છે. Okay, and why is that known as joint density of states? Because we have considered valence band, conduction band, top and bottom of both of them, and including we have designated some of the intermediate points also. Well, conduction band માં intermediate point લઈને એક સમજાવ્યું અને conduction band માં પણ એક point લઈને સમજાવ્યું. અને joint નું કારણ absorption or emission is not a process in which only one, either the valence or the conduction will take part. They both will take part. I hope you understand. In absorption and emission process, do you think only valence band will participate or only conduction band will participate?
No.
No,
ma'am.
ma'am.
Both,
No,
both
ma'am.
will.
Or
both
is
will
there any need? Yes, both will have its own role. That's why it is known as joint density of photon. The word is very important, joint density of photon. Understood?
Yes, ma'am.
Everybody clear?
Yes.
Yes, ma'am.
Fine. Yes, Megha. Is this the end? આ પૂરું થયું અહીંયા? Okay.
Yes.
Very good try. Huh? અને તમે શરૂઆત બહુ સરસ રીતે કરી હતી. LED અને photodiode થી you have started. It was a very good start. Very nice.
Yes, ma'am.
હા, હવે next PPT કરું?
Yes.
Yes, Megha, here you are.
Yes, ma'am. So, our next topic is density of states for photons. There are two radiation. First, photon is energy which energy is h nu and it is wave packet. Transition એટલે સંક્રમણ. Radiative transition and non-radiative transition. Transition એટલે સંક્રમણ થાય. Radiative transition હોય તો એમાં photon ના સ્વરૂપમાં energy release થશે. That means here the emission process occurs and this emission depends on the nature of the initial and final states. Here, see in diagram, radiative transition involves emission or absorption of a photon. Transition is one in which the energy released as a photon, the nature of the emission and depends on the nature of the initial and final state. As seen in the diagram, suppose there is an electron in conduction band and it is at E2 level. E2 level માં conduction band માં એક electron છે અને એની energy E2 છે. હવે એ electron E2 માંથી E1 માં જશે જે એનર્જી લેવલ છે વેલેન્સ બેન્ડમાં છે સો એ h nu જેટલી એનર્જી છે રિલીઝ કરશે. So when this electron makes a transition from E2 to E1 conduction band to valence band, so the difference between this E2 and E1 is equal to h nu is released by the photon. So we can say that E2 minus E1 is equal to h nu. It could also be a transition of electron from valence band to conduction band. એવું જરૂરી નથી કે E2 માંથી conduction band માંથી electron valence band માં જાય એવું જરૂરી નથી તો જ transition થાય. valence band માં કોઈ electron છે એ conduction band માં જાય E2 માંથી E1 ની જેમ E1 માંથી E2 માં જાય તો પણ transition શક્ય છે. So there will be a hole in valence band. And case number 2, in case of non-radiative transition, the energy difference is given in the form of photon. Transition, what is non-radiative transition? So transitions between energy levels of atoms or ions which are not associated with the emission or of light. As seen in diagram, suppose that there is an electron in conduction band and a hole is in valence band. Wherever the electron wants to make a recombination with the hole, જ્યારે electron છે E2 conduction band માં છે જેનું energy level E2 છે એ જ્યારે hole સાથે recombination કરવા માંગે છે ત્યારે તે h nu જેટલી energy release કરશે. So I say that, ma'am, second slide. See in diagram, E2 is in conduction, electron is in conduction band and his energy level is E2. When suppose that there is an electron in conduction band which energy is E2 and wherever the electron wants to make a recombination with the hole, then it has a make a oblique transition. તે oblique transition કરશે. This is not permitted by the case selection rule as the transition be vertical. In this case, delta K is very large and so the energy is released in the form of photons. Thank you, ma'am.
Very nice, Megha. Megha, છેલ્લું ફરીથી એક explain કરો ને ખાલી. In this case, delta K is very large. How is that?
In this case, delta K is very large and so the energy is released. Delta K છે ખૂબ જ વધારે છે આ કેસમાં because જ્યારે transition થશે ત્યારે electron અને hole નું recombination થશે ત્યારે energy છે એ photons ના સ્વરૂપમાં વધારે release થશે.
Megha, photon કે phonon?
Photons.
In this case, photons sure અને direct માં પણ photon. તમને ખ્યાલ હોય તમને તો chapter 1 માં you studied direct band gap semiconductor and indirect band gap semiconductor. Is it so? Can you correlate the entire topic with that one? Students,
Yes,
do
ma'am.
you find similarity between these topics?
Yes, ma'am.
Okay, so when there was a case of indirect band gap semiconductor rather than photon, શું emit થાય છે?
Phonon.
Phonon. So do you think it would be true for this case also?
Yes, ma'am.
And that would not be of the visible range? Megha, પ્રયત્ન કરો Megha.
I have no idea about it.
નથી કઈ વાંધો નહીં ચલો. કોઈ બીજું એક્સપ્લેન કરી શકશે this thing? Can you correlate this case with indirect band gap semiconductor? Are
Yes,
they
ma'am.
of
Yes, ma'am.
right? So this process would occur in indirect band gap semiconductor. I'll give you certain examples. From that you have to identify solar cell, direct, indirect. Solar cell.
Direct.
Which one?
Direct.
Direct. Okay. LED.
Direct. Direct.
PN junction diode.
Indirect. Indirect.
Indirect. Indirect. Right. Zener diode.
Indirect.
Photodiode.
Direct.
Photodiode.
Direct.
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 Yes, ma'am.
Yes. Direct. Fine. એનો મીનિંગ એવો થયો કે ફોનોનની જે એનર્જી છે whether it is direct or indirect, the energy of phonon would be in such a way that we can have visible frequency. But in case of indirect, that phonon will not have the frequency. The frequency of phonon may not fall in the category of visible spectrum. એટલે ઇન્ફ્રારેડ પણ હોઈ શકે. સમજાય છે મારી વાત? અહીંયા જે ફોટોન લખ્યો છે. બીજું મેડમે ગ્રુપમાં ફોટો મોકલ્યો તમને. મને કોણ સમજાવશે એ ફોટો? ચેક કરો તમારું વોટ્સએપ ગ્રુપ.
મેમ નથી આવ્યો હજુ. હા આવ્યો.
હા, ચેક ઇટ એવરીબડી અને મને સમજાવો. ચલો કોણ સમજાવશે મને? મેગા સો નાઇસ. ખૂબ સારો પ્રયત્ન કર્યો છો. નોટ બનાવીને વ્યવસ્થિત તમે મૂકેલું છે. વેરી નાઇસ. ફાઇન.
Thank you.
You can ha okay, fine, thank you so much. Now I want explanation from the other students also.